tomorrow.
Oh, really?
Okay.
Okay, well, I do not have time to do the lab today as well. Okay, before I do the Verilog, I just realized that I didn't do anything about hexadecimal or octal, so that'll be real quick. So hexadecimal and octal, just remember that your numbers are zero for hex, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, A, B, C, D, E, F, and those are the numbers from 0 to 15. And octal just has the digits from 1 to 7. And if you want to convert a binary number into hex, so here's binary, to convert it into hex, you start at the right and you get to groups of 4. And you see the value of that group of 4. So this, let me make this a different number. Let me make that 1, 1, 0, 1. So this one, 1, 0, 1, 1, that's 8 plus 4 is 12, plus 1 is 13. 13 is, the way I do hexadecimal is I know that 10 is A, so I count on my fingers. I'm trying to get to 13. 10, 11, 12, 13. A, B, C, D is 13. So this is D. Any number less than 10 is just going to be the same. Well, I'm converting it to hex, yeah. So this is 1, that's 3. No, that's not 3, that's 5. And this is 3. To take this same number and convert it to octal, I just break it up into groups of 3. 1, 0, 1 is 5, 0, 1, 1 is 3, 1, 0, 1 is 5, and that's 1. And if I wanted to go from hexadecimal to binary, you just do the same thing backwards. So if I had 1CA and I need to write that in binary, I always do groups of 4, whether like even though the leading one is, I don't need all 4, I'm still going to do 4. 0, 0, 1. C, A, B, C, 10, 11, 12. That's 12. So that's 1, 1, 0, 0. A is 10. That's 1, 0, 1, 0. So that's what it is in binary.
So you basically just convert the letter to decimal and then back to hex, or not, binary.
I convert the letter to binary, really. I did in my head, I converted it to decimal because I didn't have the chart in front of me. So this is a very helpful chart to have. With this chart, you never need to go to decimal. So if I had the binary number 1110, 1100, 0111, and 0101, starting from the right in groups of 4, 0101 is 5, 0111 is 7, 1100 is C, 1110 is E. And similarly, if I wanted to do A 2 0 and write that in binary, A is 1010, 2 is 0010, and 0 is 0000. But always groups of 4. Okay, so now Verilog. Draw the circuit corresponding to the following Verilog module. Do not attempt to simplify the circuit. Okay. All right. So we have the parameter n equals 3. We've got an input W. We've got these two inputs x and y. And x and y go from 2 to 0. So x, y. That tells me I have an x0, an x1, and an x2. And I have a y0, a y1, and a y2. And I've got an integer k. That tells me I'm probably going to have a for loop somewhere because that's what I use integers for. I also have this output z. Z also goes from 2 to 0, so I'm going to have a z0, a z1, and a z2, and that'll be my output. Then I have an always block. The reason z is labeled as a reg is because I'm assigning its value within an always block. Whenever you define what something is inside an always block, it's going to be as a reg. So this for loop tells me I'm going to start at 0. I'm going to keep going as long as I'm less than n, and I'm going to add 1 each time. So I'm going to go to 0, 1, and 2, and then I stop because 3 is not less than n. And then within this for loop, it says z of k equals x of k and, I can't do an and symbol, w, or y of k, and then end, an end module, and so this tells me that I have z of 0 equals x of 0 anded with w. That's supposed to be an and w, or y of 0. And then z of 1 equals x of 1 and w, or y of 1. And z of 2 equals x of 2 and w, or y of 2. So now I can draw this. I have a one from 2000, maybe 13 in my office. A MacBook Pro from 2013 in my office. Still works pretty well.
This thing doesn't like me. It's tired.
I'm tired. I'm tired, Grandpa.
It's really like me.
Okay, so all I did with this was I took my x of 0, x of 1, of x of 2, and I ANDed each of those with w. So I have my 3 AND gates here. So I ANDed each of those with w. And then the outputs of those, I ORed those with my components of y. So I ORed the output of x of 0 and w with y of 0. I ORed the output of x of 1 and w with y of 1, and the output of x of 2 and w with y of 2, and the OR of those is z of 0, z of 1, z of 2, and that is going to be your output, and that is all there is to that one.
How soon will you have that fixed?
Almost immediately, because I'm exporting them as, although this last one says video unavailable. We are going to convert. Nope, that sounds available to me. So let me get this last one. Okay, so was there another Verilog problem on the study guide?
The one that he presented to us
Uh-huh.
was just about spot on with that.
Oh, was it?
Just about.
Okay, let me see what,
So
I
we
have
say
here.
reg z because we use it in a for loop later.
not a for loop, an always block.
See, so if it was, if we decided to use z later outside of the always block, would that cause an error because of the reg?
It would if you change it. You can use it, but you can't change it. Let's see, is that it? Did I get it all? I did. I have like a couple minutes left before I have my next thing that I have to do. Would y'all like me to do another Verilog, or are you, you're good? You've had enough.
Is there any other different kind of Verilog
Let-
outside of
There's lots of kinds of Verilog, but let me look at the old tests and see what I can come up with. So hold on. Let me